Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 2x to the power of 6 is equal to 3. Now what I'm first going to do is I'm going to let a equal x to the power of 6. So if a is equal to x to the power of 6, then a to the power of 1 over 6, this would equal x, right? Meaning x is equal to a to the power of 1 over 6. So I'm actually going to plug in a to the power of 1 over 6 for x here. So we have a to the power of 1 over 6 to the power of 2a. Because remember, a is equal to x to the power of 6. And now this is equal to 3. Now, if we have something in the form a to the power of n to the power of m, this is actually equal to a to the power of n times m. So a to the power of 1/6 to the power of 2a is equal to a to the power of 1/6 times 2a. And this is equal to 3. Now 2a times 1/6 is simply just a over 3. So we have a to the power of a over 3 is equal to 3. So now if we take the power of 3 on both sides, we get a to the power of, remember the property, a to the power of m to the power of n is equal to a to the power of n times m. So we get a to the power of a over 3 times 3 is equal to 3 to the power of 3. Now these two simply cancel out. So for our left-hand side, we get a to the power of a is equal to, right-hand side, 3 to the power of 3. Now, if we have something in the form x to the power of x is equal to y to the power of y, then this means that x is equal to y. So let's say a is x and 3 is y. This means that a to the power of a is equal to 3 to the power of 3. Also means that a is equal to 3. So 3 is our answer for a. However, remember, a to the power of 1 over 6 is equal to x. So if a is 3, then this means that x is equal to 3 to the power of 1 over 6. So this is the value of x. So that is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 25 to the power of x minus 15 to the power of x is equal to 9 to the power of x. Now what I'm first going to do is I'm going to divide 9 to the power of x on both sides. So now we get 25 to the power of x over 9 over 9 to the power of x minus 15 to the power of x over 9 to the power of x. And this is equal to 9 to the power of x divided by 9 to the power of x is simply 1. Now, 25 to the power of x over 9 to the power of x, this is the same thing as 25 over 9 to the power of x. And same thing with 15 over 9. This is the same thing as 15 over 9 to the power of x. So now this is equal to 1. Now 25 over 9, well, 25 is the same thing as 5 squared, and 9 is the same thing as 3 squared. So we could rewrite 25 over 9 as 5 over 3 squared. And this is to the power of x minus, now 15 over 9, this could just simply be simplified to 5 over 3. So 5 over 3 to the power of x. Now I'm going to let x equal 5 over 3 to the power of x. I get x squared minus x minus 1 is equal to 0. This means that x is equal to 1 plus the square root of 5 over 2. So now if we plug this in, we get 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. Now I'm going to take the ln of both sides. So now, because I took the ln, I can actually move this x to the front. So now we have x ln to the power of 5 over 3 equals ln of 1 plus the square root of 5 over 2. And now this can be written as x is equal to, well, for ln, we could actually write this, our ln 1 plus the square root of 5 over 2. We could write this as ln 1 plus the square root of 5 minus 2, minus ln 2. Because when you're subtracting to natural logs or even to normal logarithms, you simply just divide them. So this is the same thing as this. And now this is going to be over. Now the same thing for this. ln 5 minus ln 3. So this is our answer.